A colleague of mine who used to be head of science for NASA once said, if we were in the year 9999 and we look back to now, early 21st century, what would we know? Would it be Beyonce? Would it be, what big thing would we be talking about? And it might be that we finally crawled out and started to see the bigger picture. And it were those first couple of space telescopes and a few other things, of course, in biology too, which is not my area, but that we started to recognize what we didn't know. And we started to take the risks of figuring out, what do we need to know? I mean, one of the reasons why I'm interested in Venus, because we have a sister next door that's less well explored than Pluto. So because of an engineering boundary condition problem, she's not the most convenient to go to. So, no U.S. mission's been back to the atmosphere of Venus since 1978. My God, that's, what were people doing in 1978? I mean, there were no iPhones, trust me. And,
well, she's so similar and so different from us, right? It boggles the mind, right? All of this geological activity, no magnetic field, like what is going on? She's very perplexing. And of course, everybody all throughout time for tens of thousands of years has been obsessed with Venus.
Well, yeah, and the fact that she's so different in the same neck of the woods with a story that's probably lurking in her big atmosphere, which is an ocean of air. Near the surface, it's actually only 10 times less dense than water. Really, how do you handle supercritical CO2? They do in manufacturing, but that's about it. We don't live with it. But that's the Venus of today. But it wasn't always like that. Some of us think a billion years ago or less, there could have been surface ocean waters, and it may have had mountain building more like the tectonics we know and love with our terrestrial model, but we don't know. And so the next foray of missions, commercial plus by space agencies, are going to tell us stuff. And all the kids, young folks like you and younger, are going to wake up to a new Venus. And we'll say, she may be a little harder to work at, but, let's face it, Mars is great because it's also fantastically interesting, but it's also really convenient. Electronics love being at minus 20, trundling around. It's great. You're not worried about too much. It's super. When you're at 450 C and in a caustic environment and, you have battery power for a couple hours if you're lucky, or some other power source that would require more creative things, you got to get a lot of work done fast or figure out a way to handle it. And so I see these scientific exploration challenges, the ones you were talking about, why aren't we edgier, as catalysts for the engineering to come out of their socks and solve the problem for us. To me, that's the beauty of it. Science is great. We ask the questions, we want to know stuff, but engineering solutions that let us make the progress on it. It's that partnership that crosses the boundaries and let us do things. And that, whether it be astrophysics, biology, nanoscale, everything, those are those frontiers. I like to say space is a forever frontier because, it is basically counting across how we look at dimensions. And I'll let the physicists describe all their great, multi-dimensional stuff, but it really is. But so is the nanospace that builds, the rigging to get to life and atomic, basic atoms and all that stuff. And so at both ends of the scale spectrum, we have these magical forever frontiers awaiting us to use and understand and learn from. And, we've just opened our eyes to them. It's like, what a great time. Seriously, it's marvelous.
I think that what I see here is that before you bound science by engineering, what you have is mythology almost. You have stories that you tell about what might be, and there's these massive actors, and it is theoretical and fanciful, and you have to be bordered, in order for it to be, utilitarian, you have to be bordered by what's possible in terms of, some fundamental axioms that you take to be the rules by which objects interact. But then when you take engineering is the time where everything is on the line because you suddenly can confirm or deny the mystical that you have proposed in generations before. And so when you go to Venus, for the first time since 1978, what are the things that are on the table for confirmation or for denial?
Well, we bring the tools of the trade. It's almost, it's almost Sherlock Holmesian, in a sense that we have a problem and there are clues. I mean, we have a giant atmosphere staring at us. We can't even see through it without windows in the infrared. And so, we're challenged by that. We have to be in the atmosphere. We have to sample the atmosphere. In the case of our mission to Venus, called Da Vinci, named, quite frankly, for Leonardo, but also an acronym. Have to have acronyms at NASA. But it's convenient that Leonardo gave us his name for an acronym. But our trick is to bring the labs that we have and that we use for samples from the moon and in biology, bring the labs with us to the problem. That's an engineering solution. So we make a spacecraft, it's basically like a submarine, that intakes gas and measures it at the scale we need to understand what made it, how did it get that way. We look at certain things like noble gases, which the way they fractionate tell us the history of things because they don't react. So the ratios of their isotopes are, they're fossil records of what happened to a planetary atmosphere. Was it reaccreted? Was it blown off? Was it made by volcanoes? Was it cometary? Was it cycled? Blah, blah, blah. Those tools are at our fingertips now. And we have them in the labs. Kids have them in school. We took them to Mars and 2 rovers. Blah, blah, blah. We have them on the space station with, crew, women and men working with them. Now we bring them to Venus in a robotic craft. And so to get to your question, we ask the questions of what could have been. And I think there is mythology and there's also visioneering. I know it sounds like a Disney term. It may have been started there. I will leave that to you to tell me. I heard it. And, Thomas Edison was once quoted as saying, vision's great, but without implementation, it's a dream or something like that. I mean, that's an approximation. So we visioneer what we think could have been a story for another world, like Venus. Maybe she despun and got into this weird motion that changed the way she behaved relative to Earth. Maybe she lost her oceans to the atmosphere and hydrogen was lost to space. And we have this strange planet that lost its habitability. Maybe she did something else different that we never even thought about. So we need to make the measurements that open our eyes to the possibilities because we don't even know all the possibilities. And that's what's cool. I mean, we're going to be going with Da Vinci, coming down and imaging over a 10,000-foot mountain range that some people think are the continents of Venus, which would be cool because we have continents on Earth. That's a story of old rocks. Really cool. God love them. Or a story of something new or something different because those mountains don't look like those to the things we've seen that we're so used to on Earth. And so why? Why did Venus work differently?
How are they different?
They have textures and patterns and things when seen by the radars we've used to see them that just don't look like the kind of things we have on Earth. There are some places on Earth that are analogies. The ancient mountains of the Pilbara of Western Australia, quasi-similar. The young collisional mountains of the Zagros of southern Iran, maybe. There are places that have resemblances statistically, but these are different. They're taller. They're distributed differently. Why is this jigsaw puzzle of Venus, not assembled in front of our eyes the way we've come to see our own history on Earth? We're starting to use for the moon, which is a great place to test. And, for me, I like the what if it was really good. I call that finding the pony story. You think you probably get where I'm going. So, you put a kid in a room with a bunch of stuff they don't particularly want, and they look for the pony. So I'm looking for the pony on Venus. I want it to give us the clues to tell us Venus had oceans, and it lost them. Why did it lose them? What does that speak to planets that are at the edge of a habitable zone relative to a parent sun, as we look at dozens of other ones with James Webb and with future telescopes, Nancy Grace Roman, the big HWO that's being conceptualized now, when we'll be able to see things, much better. I mean, you young folks are going to see the glimmers of light directly from exoplanets in your lifetime.
Which has really changed the way we think about our own planet, too. It's been incredible. And our solar system, right? We used to think all solar systems more or less probably look like this, and it turns out we're like the complete freak in the bunch, right?